Let's find the derivative of g of x using the chain rule and logarithmic differentiation. We're given f of x equals the square root of x squared plus 4x plus 5, and g of x equals natural log of f of x minus 1. Our goal is to find g prime of x. First, let's understand how these functions are composed together. We can substitute f of x into g of x to see that g of x equals natural log of the square root of x squared plus 4x plus 5 minus 1. This is a composition of three functions. First, we have x squared plus 4x plus 5. Then we take the square root, and finally, we subtract 1 and take the natural log. We'll use the chain rule multiple times to find this derivative. The derivative of g with respect to x equals the derivative of natural log of f of x minus 1. Using the chain rule for natural log, the derivative of natural log of u equals 1 over u times du dx. Let's start by finding the derivative of the outer logarithm function. Let u equal f of x minus 1. Then g prime of x equals 1 over f of x minus 1 times the derivative of f of x minus 1. This simplifies to 1 over f of x minus 1 times f prime of x. Now we need to find f prime of x, the derivative of the square root function. We can rewrite f of x as x squared plus 4x plus 5 raised to the power of 1/2. Using the chain rule with the power rule, the derivative of u to the 1/2 equals 1/2 times u to the negative 1/2 times du dx. So f prime of x equals 1/2 times x squared plus 4x plus 5 to the negative 1/2 times the derivative of the inside, which is 2x plus 4. We can rewrite this as 2x plus 4 over 2 times the square root of x squared plus 4x plus 5. Simplifying by factoring out 2, we get f prime of x equals x plus 2 over the square root of x squared plus 4x plus 5. Now let's combine our results to get the final derivative of g of x. We found that g prime of x equals 1 over f of x minus 1 times f prime of x. Substituting in our expressions, g prime of x equals 1 over the square root of x squared plus 4x plus 5 minus 1 times x plus 2 over the square root of x squared plus 4x plus 5. Combining the fractions, we get x plus 2 in the numerator and the square root of x squared plus 4x plus 5 minus 1 times the square root of x squared plus 4x plus 5 in the denominator. We can also write this in an alternative, simplified form. This is our final answer. G prime of x equals x plus 2 over the square root of x squared plus 4x plus 5 times the quantity square root of x squared plus 4x plus 5 minus 1. Let's verify that our answer makes sense by checking the domain. For g of x to be defined, we need f of x minus 1 to be greater than 0. This means the square root of x squared plus 4x plus 5 must be greater than 1. Squaring both sides, x squared plus 4, x plus 5 must be greater than 1. Simplifying, we get x squared plus 4x plus 4 greater than 0. This factors as x plus 2 squared greater than 0, which is true for all x except x equals negative 2. Let's review what we've learned about finding this derivative. We applied the chain rule twice, once for the natural log and once for the square root function. We found that f prime of x equals x plus 2 over the square root of x squared plus 4x plus 5. We combine these using the derivative of natural log to get g prime of x equals f prime of x over f of x minus 1. Our final answer is g prime of x equals x plus 2 over the square root of x squared plus 4x plus 5 times the quantity square root of x squared plus 4x plus 5 minus 1.